So we're doing exercise 10D, and this is question 9. Now this is a bit of a tricky question, so I'm going to go slowly through it, and hopefully by the end it all makes perfect sense. So let's read it. A 4-digit number with no repetitions is to be formed from the set of digits, and here we have right here 0, 1, 2, 3, 4, 5, 6, 7. We need to find the probability that the number is even. Now, as you see, I've already written something out here. I've written the probability of it being even is going to equal the restricted permutations over the unrestricted ones. So the restricted ones are going to include all the even ones that we have. So all the different permutations that create an even 4-digit number. And the unrestricted is just going to be all the permutations altogether, even and odd. Let's first begin by figuring out what the unrestricted ones are going to be. To solve this, we're actually going to go 1, 2, 3, 4. We have four spaces right here, which represent the spaces for my 4-digit number. We're then going to figure out the numbers, the amount of options I have to put into each space. Let's begin with the first one. So this is the first, depending how you look at it, the first or last digit of the number. It's got the first position, I suppose you could say. So right here, let's not get bogged down in semantics. How many options do I have to put in this position? How many options do I have? Well, I have 0, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. 8 because there's that 0 as well. So you could say that my n equals 8. So do I therefore have 8 options to put here? And I actually don't have 8 options. I only actually have 7 options, so 1 less. And the reason for that is because I can't put 0 here. If I were to put 0 there, that would mean, for instance, if I had just some random numbers here, is this now a 4-digit or a 3-digit number? Well, now it's a 3-digit number because there's a 0 there. So obviously I can't have a 0 there, or otherwise it's going to break down. I'm not going to be able to produce that 4-digit number. And that's why I only have 7 options. So 8 minus 1, minusing 1, because I can't have a 0 there. Hopefully that makes sense, because that really is the crux of what we're doing. You need to realize that this position cannot have a 0, and the reason why it can't have a 0 is because I would no longer have a 4-digit number. So the reason why I'm reiterating that point is because it's going to come up again and again, and if you don't understand that point, it's really going to make the question just totally unintelligible. I don't know. I'm not an English teacher. Next, let's keep on going. How many options am I going to have for the second position? Well, I've already used a number here, and I can use my 0 here. So that means I'm going to have 7 options. Then I'm going to have 6 options, and then I'm going to have 5 options. Therefore, to find the amount of permutations I could have for the unrestricted ones, I'm simply going to times all of these together. And if I do that, so now I'm going to get out my calculator and go 7 times 7 times 6 times 5. That's going to be 1470. So now I'm going to get my green highlighter because that represents my unrestricted, I'm just dying here, my unrestricted one. So 1470 over, now let's make that a green. Next, we need to figure out the restricted one. So that means all the ones that are going to be even. So once again, I'm going to begin by drawing 1, 2, 3, 4 spaces for my 4-digit number. But let's this time start with this position right here. How many options do I have for this one? Remembering that if it's going to be even, this space right here has to have an even number in it or 0 in it. So if we were to come up here, we could say, well, this last spot either has to be 6 or 5 or 2. Sorry, I can't count 6 or 4 or 2 or 0. It can either be 6 or 4 or 2 or 0. So how are we going to do this? And this is where it really becomes really quite complicated. And later on, I'm going to be showing you a better way to answer this question that isn't so convoluted. But I want to show you this way first, just so you can get a good understanding of what's going on. So again, I'm going to repeat myself. What I'm about to write isn't correct, but I think it's important that I do write it just so you understand what's going on. I feel that many of us would simply say, well, there's going to be 4 different options for this position right here because I have 1, 2, 3, 4 numbers that could go there. So let's just put that in. Well, what now will be this one? What now? How many options do I now have for the first position right here, the very first one, or the last one, depending how you think about it? What's it going to be? Well, I know it can't be 0. I know it can't be 0 because if it was 0, then I would have a 3-digit number. I also know I've already used a number here. So that's going to be 8 minus 2, which means it's going to be 6. Then I'm going to come to this position right here and ask how many options do I have? Well, I've already used 2 numbers and I know it can be 0. So that means it's going to be 8 minus 2 again. And then finally, for this one, it's going to be, I've used 3 numbers, so it's going to be 5. Now, as I said before, this is incorrect. And the reason why it is incorrect is because these 4 options include 0, 2, 4, and 6. That's what those 4 options are. But if I were to put 0 here, if I were to put 0 in this position, how many options would I have for this position right here? Well, if I've used 0, so now 0 is gone, I have 1, 2, 3, 4, 5, 6, 7. I have 7. So because I've gotten rid of that 0, I now have 7 that could be here, which means things are going to have to change. So now I'm going to rub this out and I'm going to show you the better way to approach this, knowing that there is that confusion that happens when I have a 0 in that position. And what I'm going to say is that we have 2 options. We have option 1, which means I'm going to end with either 2 or 4 or 6. And then my other option, which I'll write down here, my other option is going to be, let me say this is option 1, let me say this is option 2, and it's going to end with 0. All right. Now this is annoying me because this is ugly. Let me rewrite that. As I said, this is a long question. But if you want to understand it, I feel this is the best way to go about it. So now I can end with 2, 4, or 6. So that means this one right here, I have 3 options to fill it. It can either be 2, 4, or 6. Then I come to the first position right here and I ask, well, how many options now do I have for this first position? Well, I've already used a number here, 2, 4, or 6. And I know that this one also can't be 0. So that means I have 6 options. So remember, I've minused 1 because I have 1 there, and I minus another 1 because it can't be 0. So that's 6. Then the next one is going to be 6 as well. And then the next one is going to be 5. Remembering that this one can be 6 because I've already used 2 numbers here. So then what we're going to do is we're going to multiply all of those together. I'm going to multiply all of these together and I'm going to end up with 540. 540. Now I'm not done yet. Now I need to come down here and I need to draw 4 spaces again. And I need to figure out if I end with 0. So if I'm going to end my number with 0 here, so that means I can put this straight in. That's going to be 0. Well, if that's going to be 0, that means I have only one option to choose from. It can only be that 0 right there. Now, how many options would I now have for the first position? How many options would I have for the first position? Well, 0 is gone, so now I have 7 left. Then how many options would I have for the second position? Well, I've used 2 up, so that means I'm going to have 6. And then for the last one, it's going to be 5. So it's going to be 7 times 6 times 5. And if I multiply all those together, 7 times 6 times 5, is going to be 210. So that means there are 210 even numbers with 4 digits made up of these digits, which are even. I hope I said that correctly. And there are 540 different permutations that end in 2, 4, or 6, which are 4 digits and consist of these numbers. Ooh, that was a mouthful. I'm almost certain I said something wrong there, but I don't think I did actually. So now what we're going to do is I'm going to plus these together to get the total amount of even numbers. So to get the total amount of even numbers, I'm going to go 540. Oh, I'm just losing my mind. 210 is going to equal 540 plus 210 is going to equal 750. 750. And I'm actually going to write this in black. 750. 750. And that, my friends, is the blue number. That is my restricted one. So I come over here now and I write in, let me zoom in. I write in 750 and I highlight it in blue. I then go 750 divided by 1470 and I'm going to get the number 25 over 49. So it's going to be 25 over 49. And that is going to be my final answer, 25 over 49. Now we've just done A. Whew. Now, let's go on to B because it's all related. I'm going to do C and D another day. And what you're also going to see is that I've actually cheated a little bit. I've included some of the working out already because it's going to be basically the same. Now, before we go on to that, there is a very easy way we could solve this, a very easy way. Once we know what the probability of the even number is, all we really need to do is, let me come over here and just use some blank space. If I know what the probability of the even number is, all I need to do is say, well, the probability of odd is going to be 1 minus the probability of the even. Therefore, it's going to be 1 minus 25 over 49, which is going to be 24 over 49. So the answer to B can be solved quite easily by simply doing that quick arithmetic, knowing that 1 is going to equal the probability of the even plus the probability of the odd. But I do want to show you an even more efficient way to answer this question in totality. And what I mean by that, and what you're going to see now, is that it was really quite convoluted to figure out the probability of the even number. And the reason why it was so convoluted is because, as you can see here, we had to do it twice because we got a mix-up with whether or not we could have a 0 in our last position right there. So if you realize you would have that difficulty, something you could have done to circumvent that is simply say, well, what's my odd number going to be? So that means, for those of us who are really thinking ahead, you could have simply said, you know what, I think finding the probability of the even is going to be a bit tough. Instead of doing that, I'm just going to find the probability of the odd and then go 1 minus that to find the probability of the even. So it really does take quite a bit of forward thinking to do that. So let's really get into it. So if you were to find the probability of the odd, it's far simpler. And the reason for that is because we're going to have 4 positions we have to fill. And we know that the last position right here, the last one, is going to have to be odd. Now, if the last one is going to have to be odd, it's either going to be 1 or 3 or 5 or 7. 1 or 3 or 5 or 7, which means how many options do we have altogether? We have 4 options. We have 4 options. And let's notice that one of my options isn't 0. So we don't run into that problem as we did in part A. Now we have to fill in the rest of them. How many options do I have to fill in the first position? Well, if I've already put 1 in here, that means I'm going to have 7, but also remember it can't be 0. So I'm actually only going to have 6. So remember, I'm minusing 1 because I've used it here, and then I'm going to minus another 1 because I can't have 0 there. Then my next position, how many options am I going to have? Well, I've already used 2, and this time I can have 0. So it's going to be 6. And then finally, it's going to be 5. So, oops, if it wants to work. So now I'm going to multiply all of these together. So 6 times 6 times 5 times 4. 6 times 6 times 5 times 4 is going to be 720. Let me do that in black. 720. And then I'm going to highlight that in blue. I'm going to highlight it in blue. Where's my blue? There it is. Then I'm going to come up here and write in 720 and going to highlight it in blue again. So notice how quickly we were able to find this in comparison to the last one. And my answer is 24 over 49. And that's what we found before when we did it the quick way. like that. Perfect. Now, as I said before, if you really had hindsight and you realized you're going to have that difficulty of the 0 on the end, what we saw up here, if you realized that we were going to have all this trouble finding the probability of the even, what you could have done is done this. So find the probability of the odd. So this is what I'm calling the easy method. First, the easy method would be finding the probability of the odd and then going the probability of even is going to equal 1 minus the probability of the odd. So you would find the probability of the odd, which you know is going to be 2449, and that is going to give you the probability of the even, which is going to be 25 over 49. So that would be the easy way to do it. But as I said, this was a tricky question, and you should be happy with yourself if you got close to the right answer. And if you did get the right answer, I was talking to a few of you, some of you did get the right answer, and that's absolutely amazing. I'm really happy and proud of you if you did. But yeah, tricky question. Hopefully that explained it and allowed you to appreciate the complexity of everything there. All right, in the next video, I'll go through C and D, but at the moment, I think you all need to take a break, as do I.